And here, so I just fixed that slide. And you see, if you have the displacement as a function of time, if you take the derivative, okay, so you're going to get a function, and that will be velocity as a function of time. If you do graphing analysis, so that means you are using a graph, then the slope at a given point, which is the steepness of the tangent, that will give you the velocity. Okay, so it's always nice, even in engineering, to rely on graph. Okay, you can, it's so much more easier. Then if you have the velocity as a function of time, so that's a function like f of x, you take the derivative and you get the acceleration. If you are using graphing analysis, so at a given point, okay, so if you take a given point, a given time, you take the slope, which is again the steepness of the tangent. So I just tangent the angle, right? How steep is the line? Then you get the acceleration. If you want to undo, so the opposite direction, if you have the acceleration as a function of time, you integrate the function and you will know the velocity plus or minus a constant, right? So it will depend on the initial velocity. So if you do integration, you know what I'm talking about. Otherwise, if you rely on a graph, then you just find the area under the graph and you will find delta V, which is final minus initial. Same way, if you are given the velocity, okay, and you integrate, you're going to have the displacement, or given the graph, you can find the area and you will find delta x. So I try to make it clear here. If you have issues, right, because I know you didn't take calculus, I encourage you to use app. It's on your phone, you can download an app and they will break down all the steps. So me, I'm old school, so I use Wolfram Alpha, right? So if I say integrate that polynomial, it's going to give me the answer here plus a constant. If you buy the membership, like if you buy, it's like a little fee, like if you're a student, they will break down all the steps. But you have the same thing with app. I don't know the name of the app, but they will break down everything. Okay, so that can help a lot. I like this one because you can graph. So you really visualize what's going on. So anyway, that was a parenthesis here. And again, here I have updated the slide. I put the solutions. Even that solution here, I didn't do it all the way because it's mostly math and I'm teaching physics, not math. But you can do that on your own. Calculus, of course, is very important. It was invented by Newton. So you need calculus for everything, engineering. And so we did that here. We did that example here. Okay, so we're going to go back to that. Okay, and you have the app. So again, I used an app here, and you have it in Canvas. I have it here, but you have that app in Canvas. Okay, it's this app. So we already played with it. Okay, so I'm not going to play with it again. You have to do that on your own. But you can see, in that case, it's a constant velocity. So it's moving to the right and it's moving at a constant speed, which means every second, the object, which is a car, is going over 5 meters. Agree? Okay, so that will be for the velocity. There is no constant. And then if you use position as a function of time, you have a line. Okay, so that means at x equals 0, the position is 10. So that will be initial position on the number line. When you start your stopwatch, every second, so every run, every step in 1 second, you're going to go further by 5. Okay, so 5 plus 5 plus 5. Okay, so that means it's a linear relationship. The slope is 5. So the slope of position versus time is the velocity. That will be your initial position. So I encourage you to use the app that you find in Canvas. Yes. Yeah, so if you find, so in that case, it's easy, so we will not use it. But if you integrate, for example, if you integrate 5, okay, you're going to find 5t plus a constant. Yes, and you can find also if you integrate between this and there, okay, you're going to find the time, that will be the base, times the height, which is 5. So 5t. So if it's not linear, no, usually the thing that you will get will be something like this. So you will be easy to break into pieces. So if it's a parabola, you have to integrate, right? Okay, so here is another example, moving at left at a constant velocity. What I want you to see here is that the velocity stays the same. It's negative, so it's moving to the left. There is no acceleration. When you're going to graph, okay, so graphing here, you see it's moving to the left because it's coming back toward the origin here. So you start at t equals 0, that will be initial position, and it's losing, it's coming back. Okay, it's going to go to the left. Is that clear? Okay, so any science that you do, you try to make graphs, especially in engineering. Okay, so here we have an example where now it's accelerating. What does it mean accelerating? You start your stopwatch here at t equals 0. You had a velocity to begin with, that will be the initial velocity, and every second you're going to go further and further and further away. So kinematics, it's very deterministic, right? And it says that you can predict the location on the number line given your acceleration, given your initial velocity, and that's how you have this equation of motion. That equation of motion only works when you have a constant velocity. Yes? Yes. So initial velocity, yeah, so velocity graph, that will be your initial velocity 5. So t equals 0 is going to be 5. And then you increase by 2 every second. So that means you start at 5, and then 1 second it's going to be 7. 1 second it's going to be 9. 1 second it's going to be 11. So that will be the definition of a linear equation, because for every run of 1, the rise is always the same. But the position, no. The position is a parabola. So every second, here you move by 6 meters. Another second, you're going to move by whatever 24 minus 16 is. And then you move by another bigger step. Okay? And that will be the equation of kinematics, the equation of motion. That's going to give us the initial position, the initial velocity, and that will be 1/2, that will be your acceleration. So that will be a constant acceleration. You can visualize that on the number line. You're going to go further and then further and then further away. If we derive, so if we take the derivative of this, you're going to get 5 plus 2 times 1/2 times 2, which is 2t. And you derive again, and you're going to get 2. Okay, when you take the integral, then it will be delta. You have to take into account the initial velocity. So it's called the initial conditions. You learn that when you're going to take a differential equation. So, but that's easy. Is that clear? Okay. And then here, So I have included this slide. This is for my algebra class, but I thought, okay, does not hurt. You see here the position stay constant. Obviously, you are not going anywhere. So no velocity. If there is no velocity, there is no acceleration. That will be position versus time. If you have a constant velocity, okay, so the slope will be the velocity and you have no acceleration. If you have a constant acceleration, you get a parabola, also called a quadratic. The equation will be a quadratic equation. You take the derivative, you get a line, and the slope of that line will be the acceleration. Yes? I don't know. It says play the GIF. I forgot what the GIF is. Okay. Example. So this one is moving at a constant velocity. This one is speeding up. See, you don't have the same graph. And at some point, he's going to catch, or she's going to catch up. So again, if you have a graph, so f of x, at a given point, you can find the slope of the tangent line. Why do we call that the tangent? Because if I want to find that slope, right, the steepness, you find the tangent of the angle, right? So what's the slope of that line will be just the tangent, opposite over adjacent. Okay, if the slope is this way, it will be positive or negative? Negative slope. That will be a positive slope. What's the slope here? 0, and here it's infinite. Okay, so easy. Let's start something easy. So let's go quick. Position versus time. The slope will be what? Look at the unit. Rise over run. Meter per second is the unit for velocity. Very good. Wake up, wake up. So rise over run in that case is 4. So 4 meter per second. If you forget what the slope, which physical quantity is the slope, you look at the unit. Rise is meter, run is second. Meter per second is the velocity. So last time, if you have position versus time, if you take 2 points on the line, we have seen that the slope is the average velocity, okay? Average means the change in position, so the displacement, over the change in time. However, if you bring that point very, very, very close to the first point, you're going to get the instantaneous velocity at a given point, okay? So, for example, if you have a parabola, it doesn't have to be a parabola, whatever graph that you have, you see, you take that point, so at t equals 20 seconds, if I find the steepness of this line, which is called the tangent, that will give us the very good instantaneous velocity at a given time. And I will just have to do run, rise. Okay, you run and you rise. So that will be 26 divided by 5. Okay, so easy. So what do you think the slope will be? Now I have velocity as a function of time. Very good, right? So rise will be meter per second. The run is second. Meter per second is the acceleration. So now the slope is the acceleration, which will be rise over run is 6 meter per second, which means every second I'm going 6 meter per second faster. Easy. That will be the y-intercept, which is the initial velocity when you start your stopwatch. Okay. So let's look at this here. So these types of problem are not easy. So this one is an easy one, but sometimes it's not that easy. So if you look at the graph here, do we have a positive slope or negative slope? Positive, which means this guy is moving to the right. Okay, because it's positive, velocity has a sign. So what's the velocity or the speed? It will be 400 divided by 200, which is 2. So what's the slope here? 0. So it means he's tired. He's doing the Tour de France. I know if you've seen the picture that made the buzz, right? You didn't see that, the Tour de France. He's Polish, the athlete, and he posted a picture of his legs after 17 days in the Tour de France. You have not seen that? I will show you. So anyway, so what's going to be the slope, positive or negative? Negative. 400 by 400 is 1, so he's getting tired after doing 17 days Tour de France. I don't know if I can find I think it was on it was everywhere. Legs of athlete after Tour de France. Polish guy, I forgot his name. You didn't see this picture? But it's fine, okay? I wanted to understand why. So first of all, you lose so much fat that because you lose so much fat, you can see the vein here more, and that will be bruised, I guess, you know. And he said he was fine, but he took the picture of his knees, and I say, wow, that's crazy. Okay, so you should be able to analyze situation like this. So the velocity here, what's happening? Are you at a constant velocity, speeding up, slowing down, whatever? What's happening here? Okay, so the velocity is going to increase in magnitude. So you are speeding up, right? You can find the acceleration by doing rise over run, which is maybe 2/2, maybe 1, something like this. So the magnitude increases. What's happening here between 2 and 3 seconds? Look at the magnitude. Decreasing. The acceleration is negative, but you are still moving to the right. So you are moving to the right, okay? You are moving to the right because velocity is positive. You are moving to the right, but you are slowing down. So first you speed up and then you slow down. What's happening here? Here, at that point, stop. And now look at the sign of the velocity. Is it positive or negative? Negative. So it stopped, reverse, and now it's moving to the left. But look at the magnitude. Is the magnitude increasing or decreasing? Increasing. So it stopped, reverse, spinning up at left. And you see that the acceleration is also negative. So negative velocity, negative acceleration, you speed up. So sometimes it's not that easy to interpret a graph. Okay, so in that case, the red car, okay, is moving at a constant velocity. At t equals 0, you see he was in front of the blue car. Do you agree? Right, the position is further away on the number line, and the blue car at t equals 0 is at rest, and the red car is not at rest at t equals 0 because it has a acceleration. Is going to speed up and catch up. So my equation is to predict. So typical question on the test, where is it that they're going to meet, right? So I'm going to take an app here somewhere. Maybe here. Okay, so you have two cars. The blue car start at 0. Okay, the blue car starts at 0, and the velocity is 24, so it was moving. Okay, it was at t equals 0, when you start your stopwatch, it was moving, and there is no acceleration. It's very hard. This one?
No, in the little box where it shows you the number.
No. Oh, yeah, you're right, thank you. Okay, and then this one, we're gonna say x equals 0, no initial velocity, and acceleration is 10. So start. So you see the blue car had velocity to begin with, and it's moving at a constant velocity. The red car, when you start your stopwatch, it was not moving and it started to accelerate. And boom, they catch up. So how can we find the time at which they will be at the same place and at the same time? At what time the red car is going to pass the blue car?
Right.
So yeah, so how are you going to do that mathematically? Two equations. Exactly. So the red car will have, what's the equation for the red car? 10. 10 is the acceleration, so it will be 1/2, right? 10 t squared. Do you agree? Because it has no initial velocity and no initial position. And the blue car, x equals 2040. Okay, so we have two kinematic equations, and you need to solve for time first, right? So why don't you do that? They are equal to each other because we are trying to find this here, right? So we try to find the position. Well, they're going to be passing, I mean, the red car is passing so that will be the time, and that will be the position. So do it, don't stare, do it. It's not that hard. So we have 0.5, which is 5, right? So 5t squared equals 24t. Yes. So t equals 24 over 5. So t equals 4.8 seconds. Do you agree? By the way, if you are in a math class, your professor will complain that you get only half the point because you are missing a solution which is t equals 0, which in physics we don't care. Okay, we are not interested. We want this one. But if you are in math, you will need to give that other solution. T equals 0 is also a solution, right? So then you can find the x, right? So it's going to be 24 times 4.8. So x will be
15 foods.
right. I'm gonna count. So we have the point 4.8 seconds. The position is 115 meters. That point here. Okay. So if I go back to the app, you see that point here is about 4.8, so about 5 seconds. And that point here is about 115. Okay, can do that again. The blue one is moving, and this one is catching up. And then you can make it more complicated. So from your book, let's do 2.5. If you have it in your tablet, Otherwise, 2.5. So it's easy. It's an easy one. So that's from your book. Okay, I try to stick to the book. It's a very nice book. University Physics. So it looks like confusing, but it's the same thing, right? There is a sign here where it says speed limit. And here you have a police officer, and they always do that. They hide. So it's at stop, and he's watching. And when you start the stopwatch, the car here is just moving, okay, at a constant speed, 15 meters per second, right? So he's just cruising. It doesn't say he's spinning up. It's just cruising. It's cruising. And so it's moving at a constant velocity. So on the number line, you always want to make your number line here X. That when you start your stopwatch, and the initial position will be equals to 0 for both. And the police officers start to speed up. So first it was at rest, so he speed up, and and then you are in big trouble. So acceleration is 3. Okay, so if you do your graph, x as a function of time, so the first car is going at 15, the slope is 15, and the police officer start at 0. Okay, so the slope at t equals 0 is 0, so it's just a nice parabola here. It's going to catch up here. Acceleration is 3 meters per second per second. Okay? So what you get? So same thing as before. For the cruiser here, x equals 15t. For the police officer, we're going to have x equals 1/2 3t squared. So what's the, so it's two equations with two unknown. T equals, very good, 10 seconds. And if you plug in x equals 150 meters, do you all agree? T equals 0 is another solution, but of course here they will be at the same position, but we don't care. Okay? So I really highly recommend that you use that textbook. So some conceptual question. What's happening to train number 2? Is it going at a constant velocity? Yes, very good, right? Because the slope stays the same. What's happening to train number 1? Slowing down. What's happening here? Yeah, it's almost at the train station. So what's happening is that train number 1 at the beginning is in front of train number 2. Because if you look at a given time on the number line, the red one is in front number 2. And then because it's slowing down, train number 2 is going to catch up. Now, is there a point where the two trains have the same velocity? So remember, the velocity is the slope. So is there 2 points where the slope is the same? Yes, where? No, here when they intercept, the slope is not the same. In the middle, yeah. So at that point here, just in the middle here, at that point they have the same velocity. Okay, because this one is slowing down, this one move at the same speed, so this one at that point here they will have the same velocity, and then he slow down. It sounds like if you take a calculus class, when they are doing the proof, right? At some point you talk about that. The calculus theorem. Oh, I forgot my calculus class. Sorry. Which one has a negative velocity? A, B, C. Oh, it says here A, B, C, D, E. C, very good. Excellent, right? So C, okay, the velocity. A negative constant. So velocity, yes. So this is a velocity versus time. So the slope will be the acceleration. So the slope is the acceleration. Is the slope negative or positive? Negative. So that will be a negative constant acceleration. Now, what's happening to the velocity? It decreases, right? So it's slowing down, slowing down, slowing down. Stop. And then speed up. A. So if you look at the slope, so the slope is 0. Very, very good. So what's happening to the slope? So first is 0. The magnitude of the slope is doing what? Increase. Okay. So the acceleration so will increase. You're gonna have, it's not a constant acceleration, and the acceleration will be what? Negative or positive? Negative. So we have an increasing acceleration. It's negative, and the velocity is positive or negative? Negative. So negative acceleration, negative velocity, that means it's speeding up. But it's not like a quadratic equation for x, right? It's another graph. What about here? Is there an acceleration? No, no acceleration because the slope is 0. And the slope here is what? Positive or negative? Positive and constant. The velocity is positive, so it's accelerating at height. Okay, so which one? So we are not talking about velocity. Think about speed, which is the magnitude. In which case, it's slowing down, stop, and speed up. So the last one, you see the slope keep increasing. So in the last one, it's speeding up. Just speed up, speed up, speed up like crazy. So the first one, you see the slope is decrease, 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 decrease in magnitude, no slope. And then the slope is going to increase in magnitude. But it's negative, which means it's moving, for example, up, slow down, stop, speed up and down. So for which starts slowly and speed up. Oh, it doesn't say slow down, stop, and speed up. So in that case, what's happening here? So it's going to slow down and stop, right? The velocity, yes, the velocity is 0. So slow down and stop. So I guess it's a bad wording. So this one is speeding up. Oh, it starts slowly and speed up. Yes, you're right. You're right. I thought it says slow down, stop and speed up, but it says start slowly and speed up. Very good. I was checking if you are paying attention and read, which I didn't do, right? I didn't read. You're right. So start slowly and speed up. Okay, so that one should be easy. So this one, yeah, there is no mistake, right? Just read here. So what do you think? Is it speeding up? Is it speeding up? No, it's slowing down at all time. Because look at the slope. This is the slope, right? The slope decreases, 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 get to zero. Okay? In that, so it starts like this, slowing down, slowing down, slowing down, stop, but in that case, it starts to speed up again. So this one is slowing down at all time. Agree? Okay, so this one I keep for the assignment, but it's a 3 phases motion. So in the first phase, just look at the graph. What's happening here? Speeding up. Very good at a constant acceleration, right? Because we have velocity versus time. So speeding up, moving to the right and speed up. What's happening in phase number 2? So it doesn't stop because it has a velocity. It's cruising at a constant velocity. Do you all agree? So there is no acceleration. What's happening in number 3? So the is slowing down. Okay, so the velocity is positive, but it's slowing down. Okay, acceleration is negative. The magnitude of the speed decreases, so it's going to slow down. And then we stop our stopwatch and we don't know what's going on. Do you agree? So you can always look at the magnitude. See, the magnitude is decreasing, so that means the speed decreases. The slope is negative, which means the acceleration is negative. So you are moving to the right, but you slow down. So that's for the assignment. So that will be for the assignment as well. Here you have an acceleration. Here it's moving at a constant velocity. And what's happening here? If the acceleration is negative, you are moving to the right. Slowing down. Okay? If the velocity and the acceleration have opposite sign, you are slowing down. Okay? So this is an example that we're gonna use for free fall. So in free fall, you can drop an object here. It's gonna speed up at down. So in that case, the velocity is positive or negative? So up is plus, down is minus. So the velocity is negative. It's speeding up. So the acceleration is also. So if they have the same sign, it's speeding up. If they have opposite sign, they're slowing down. So velocity is negative. Wake up. Like this part is participating. Wake up. So the acceleration is negative. So it's speeding up. Do you agree? So this is called free fall. Except my app didn't have a -10. That will be acceleration on Earth. So let's say you are on another planet. The acceleration is -2. You see that the velocity is always negative. So it's moving down. Okay. But the acceleration is also negative. So it's spinning up at down. What's happening with the slope here? So the slope increase or decrease? increase, but it's spinning up at down. So I'm going to move to my algebra class because I have a better slide just to make sure you understand, except this is not the right slide. This is not the right side either. This is the right slide. Okay, -2. What does it mean? At t equals 0, what will be your velocity? 10. After 1 second, it's going to be 8. Another, no, is it this one? No, it's not that one. Oh, it's the same thing. It's the same slide, right? So it's for the next ones. So anyway, at t equals 0, your velocity is -5. The acceleration is -2. At t equals 1, the velocity will be -7. Okay, you change by -2 every second. Another second is going to be -9, -11, right? So it's like something falling on another planet, it's spinning up. You are using the equation of kinematics here. Okay, that will be the position as a function of time. So you are going down, but you are speeding up. Is that clear? You can move from -2. Okay, so velocity will be -5 minus 2t, so it's always negative. You see, it's always negative, which means it's always going to the left or going down. The position as a function of time, it's still a parabola, but you see that the slope here is negative. So the velocity is negative, and what's happening to the slope, it's going to be increasing. If you are not sure, do that, okay? Plug it in until you understand and use the app. So now we're going to move to another situation. So that was a situation when you drop something, agree? Now you can do a second thing here in free fall. You can throw something in the air. So what's happening in the first step? From here to there. Slowing down, very good. Is the velocity positive or negative? Positive. Right, so gravity will be, so it will be positive or negative? Negative. So velocity is positive, acceleration is negative, it's going to slow down. At the top, what's happening? It stops. So typical conceptual question for the test, is acceleration 0 at the top? No, because gravity never, ever give up on you. Keep Exactly, keep cooling down. So velocity is 0 at the top. And then what's happening? Velocity is negative, acceleration is negative, and it speed up. Acceleration is a force. Gravity is down, acceleration is down. So you can see that here. At t equals 0, it's at 0. At t equals 1, it's going to be going up, 9. T equals 2 is going to be 16, 21, 24, 25. Coming back, 24, 21, 16, 9, 0. And you can appreciate the symmetry. You start from here, you're going to go up to a maximum here, and then you're going to go back down. It takes as much time to go up that it takes to go down. The velocity is going to decrease, right? Start at 10, 8, 6, 4, 2, 0. Okay, I did it here. 10, 8, 6, 4, 2, 0. Stop. -2, -4, -6, -8, -10. You see, perfect symmetry. Isn't that awesome? Right? And that will be the position as a function of time. Okay, so we're going to see that in free fall. In free fall, you always have two situations. You drop something, boom, or you throw something like this, slow down, stop, and speed up. See, when you hold, you have to pick up on 2 steps. Up, 3 steps. Okay. So easy. So if there is a non-zero acceleration, that means the speed can change, the direction can change, so it's better to say that the velocity will change. Okay, so the acceleration is the change, the rate at which the acceleration is the rate at which the velocity is changing. Either you are slowing down, or you are speeding up, or you are turning. Okay, so I will let you do that on your own. Okay, you can practice some calculus here. Kind of calculus, you see you have position versus time. So at the beginning, the velocity is 0, very good. What's happening to the slope in that very small segment here? Increasing, very good, so you're accelerating. What about the slope here? Constant, so constant, you are cruising. What's happening to the slope between here and there? Decreasing, slowing down. And there you stop because the position stays the same. So if you do graphing analysis, from here you can go there by computing the slope. And you make your graph. And from there to there, you can also compute the slope. Acceleration is the slope of velocity. So here you have no slope, here you have a constant slope, no slope, negative slope. Okay? Have to stretch it a little bit, right? Okay, U-turn. This one is more challenging, tiny bit more challenging. So to do this one, you have to draw situation. You have to draw the situation. And we want to do it using a graph. So you want to have your number line. Where is the initial position? Where is the 0 on the number line? You want to have your 0 on the number line, and you want to know where are the cars when you start your stopwatch. And you want to have them both in the same frame of reference, this one.
Or to year 0, because car A is 300 meters behind car B, right?
Right. So on the number line, they need to be on the same number line and your height, okay? So one, you say, okay, it will be at the origin, so the other one will be 300 meters in front. Okay, so the first thing, the number line, both of them in the same frame of reference. So you can talk to each other, you can help each other. First, you have to draw. Always try to, even engineering, you want to draw the situation if possible. Okay, so I'm gonna make a number line first. That's my number line. And I want to make the origin here. So car A, blah, 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 car B, blah, blah, blah. Car A is 300 meters behind. So I'm going to make my car A here. And this is going 22. And then car B is in front. So I'm going to put my car B here. I'm going to make it in another color, right? Car B here. Initial velocity is 29. So that one, you start your stopwatch. Okay. Okay, so then there's a pull here on car A because he hit the gas. So that will be 2.4 meter per second per second. And car A doesn't, there is no acceleration here. Okay, so car A, it was going at a speed when you start your stopwatch. When you start your stopwatch, it's at the origin, but it has an initial velocity. So I'm not going to do flat here. I'm going to do something like this. T equals 0. The position is 300. So that's why you have to do a drawing. Otherwise, it's very hard without it. So don't stare, do it. There is nothing to stare here, just do it. So this one, initial position is 0, initial velocity is 22 plus 0.5, 2.4 t squared. This one is x equals 300 plus 29t. Do you agree? Yes? So you cannot solve like by staring at it. Nothing will pop out. Okay?
But the acceleration. Or not the
No, because it's always a constant acceleration, so you always use this equation, right? So it's 1/2 acceleration t squared. So always the acceleration is constant here. So then physics is done. Math takes over, which is kind of an issue because we have to deal with a quadratic equation, right? So then you have to take your TI, and if you know how to use your TI, you can solve any equation. You just need to know how to use it, which I'm not going to teach you because you can look up online. So you're going to have an equation like this, and you need to solve the equation. So usually what will happen here is that you have multiple choices, right? So you go back to the answers and you plug the time until you find the right answer. Or you take your TI, I can show you after the class, but there is a way with your TI to solve the equation. Yes, or you know your quadratic equation formula, that works too. So anyway, if you do that, you find t is about 19 seconds. And once you have the time, then you can have the position. Question? So you need to know how to do it, right? With your TI, if you know how to use your TI, with the TI, you see it says calc here, you can do derivative, you can do integral, and somewhere there you can solve. Okay, this is called solve. You can solve equation. You can solve equation here. I forgot how to do it, but you can do it. I don't know. Let's try this one, but quickly. the last one, help each other, talk to each other. It's about drawing. Once you did the drawing, this one is easier. I think this one is easier. T, 19 seconds. And for the time, you have to plug up. So this one, you have to do it in 2 steps. So X, the X, always the number line. So if you are not given information about the position at t equals 0, then of course you want to take it at the origin. So the acceleration is negative. So I like to do that here. So it means there is a force pushing to the left. So it's gonna go here and then slow down, blah, 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 and then stop. So do it, don't wait for me. Go here and then down and then slow down. And here you stop. So V equals 0. What else is given to us? The displacement. So remember that you need 3 things, right? So we have final velocity equals 0. Initial velocity is 26. Delta x is 120 meters. So the first step, I'm going to find the acceleration. So find the acceleration. Use one of the kinematic equation. You have your equation sheet next to you. Remember, V final equals initial square plus 2 times A delta x, right? So plugging in, final is 0, initial is 26 square, plus 2 times acceleration is, we don't know. Displacement is 120. So the acceleration is negative 2.8, exactly. Who said that? Yes. What's your name? Danny. Tell me your name when you participate. Meter per second. So that will be the first step. And then you see the challenge is that they didn't tell you that you should do it in 2 steps. That's the only challenge. And then you say, so he breaks here 60 meters. So it means that you want to know how fast it is going when delta x equals 60 meters. Okay? So now we have the acceleration, same thing. We have the initial velocity, which is 26. And now delta x equals 60 meters. Oh, and what do they want? They want the final velocity. Okay? So do it. More you do it now, easier it will be. You can help each other. So you can use the same equation, right? So V square equals 26 square plus 2 times negative 2.8 times 60. And then and then you take the square root. Ay, 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 ay. So what do you get? 18. Okay. About 18. Okay? So you can do the other one if you want. Okay, so let's talk about free fall. So free fall, the understanding of free fall means there is no air resistance. So free fall means either you drop something on Earth, so the acceleration is always -10, okay, because acceleration is the force per unit mass, so it's always gravity pulling, or you do this, slow down, stop, speed up. That's all it means. So it just means that acceleration will be always -10 if down is negative. Okay, so it's just the same thing that we have been doing, except that now we decide that the acceleration in magnitude is always 10 or 9.8. Okay, so that will be the magnitude. Or when you take in account the direction, it will be -10. Agree? Or 22 miles per hour per second. So anything falling will speed up by 22 miles per hour. Every second, 22 miles per hour faster. Okay? So, okay, that's my time. Okay? So, free fall, you see, with a high speed camera, you can really visualize. And free fall means that if you remove the air, anything will fall at the same rate. And I think I've done that experiment, right? I forgot. But if you take, of course, something heavy, something light on Earth, of course, it can reach the ground first. But that's because of air resistance. If you shield the heavy one, I mean, if you use this one to shield air resistance, like this, they reach the ground at the same time. So that was demonstrated by Galileo Galilei. And just as an interlude, I can show you there was a very nice demo. So I'm going to skip around. So this physicist is very much, he's big in string theory, but he's a very good public speaker. He explained very nicely. So he has, like, if you're interested, he even has videos where he explains quantum physics or particle physics. So anyway, free fall. Can you hear? Because I don't know if it's connected to the sound. Okay. Fine. Is that the sound here? I don't know. It doesn't say. I cannot see anything. What about if I do that? No. Ah, almost. Huh? Can you hear? So this is in Cleveland, Ohio. It's a vacuum chamber, and they used to do experiment with spacecraft, to recreate the vacuum in space. So you can take the air out, right? It's huge wall. Is what? Oh, because they didn't take the air out. You have huge pump, right? So that's before they remove the air. Do you know what's gonna happen to you if you are inside and you remove the air? You blow, air explode, even worse, right? Explode. It's not very pleasant. Can you hear? Yeah, because you have to be careful if you have a vacuum, right, and you have air pressure pushing like 15 pounds per square inches, it can crash, collapse. So you don't want that. That will happen to your lungs if you dive very in the ocean. Yeah, the lungs will be squeezed. So anyway, the point he has feathers and a bowling ball. So that will be with air resistance. So nothing special about that. That's what you expect, of course. Air resistance. The feathers will reach terminal speed quicker, slower, quicker. That's why they move at a constant velocity. So it's gonna remove the air. Da, 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 da. So they are pumping the air out. Isn't that cool? So that was a genius of Galileo. Without access to a vacuum chamber, he did experiment to show that, right? If you remove air resistance or friction, they fall at the same rate, regardless of the mass. Okay, so that's a very cool experiment. Usually we do that experiment, right? We have a tube, you can remove the air and you can do the same experiment. So that experiment was done on the moon. It's very famous. It was Apollo 15, David Scott, 1971. So he dropped a hammer and a feather at the same time on the moon, and on the moon there is no air resistance. So it's a very famous video, unless you think that we have never been on the moon. So like it's something now. So 1971, right? So it's a very cool video. It's very famous as well. So how did Galileo figure it out? So he was a genius, obviously. So the stories say, so first he was working at University of Pisa in Italy, obviously. And he was a professor. And the story says he went to the Tower of Pisa and was releasing heavy objects, but one heavier than the other one. And they both hit the ground at the same time. But that's a myth. That will not be possible. First of all, because I don't know if you've been there, I've been there, you know. Imagine going up those crazy, crazy stairs and then going down and going up. But mostly because he didn't have stopwatch. He came up with a way to measure time, but no stopwatch. He had like a genius idea, right? He came up with what we call inclined plane. So what are inclined plane? You see, it's a ramp here. What's amazing about it is that gravity is still pulling on the ball that he was releasing, but gravity is diluted. So instead of being negative 10, it will be, for example, depending on the angle here, it will be negative 3 or negative 2. So it was going down. So it was in free fall, okay, but the acceleration will be much less. So he had time to make time measurements. So already this is genius. You can go to Florence, which is there is a science museum over there, and you can see his inclined plane here. So already the guy, that idea was genius. So if there is an angle here, okay, we learn that the acceleration will be the acceleration due to gravity, so 10 times sine of the angle. And each time you multiply by a sine, you get something, it will make the number smaller, right? Because that will be always smaller than 1. Do you agree? So for example, if this is, 30 degrees, so you're going to get an acceleration of 10 times sine 30. Okay, so now you have, what's happening here? 10 times sine, maybe I'm not in degrees. That's why. What's happening? Oh, I'm still in. You see why? Always with your TI, make sure you are in degrees. Okay, so the sine is 0.5. Right, sine 30 is going to be 0.5. So acceleration will be 5. So half, right? So the acceleration is diluted. Okay, and then he used something to measure the time. If you watch carefully the picture here, can you see what he used to measure the time? So they didn't have stopwatch. He didn't use his pulse. He used something that he figured it out. He figured it out how it works when he was 17 years old. Do you see what it is? A string with a mass. It's called a pendulum. When he was only 17 years old, he figured it out that you can measure the time with a pendulum. If you take 25 centimeter long pendulum, it will take exactly 1 second to go back and forth. So he found a relationship between the time for one cycle and the length of the pendulum. So the guy, very smart. And then, so what he did here, what do you see here? What do you think this is?
Second mark.
They are marker with a little bell. So he was able to slide up and down the bell, such as it will take exactly 1 second using his pendulum to go from here to there. 1 second to go from here to there. 1 second to go from here to there. Isn't that smart? Right? So what did he find? He found what we call the law of odd numbers. So it means after 1 second, it moves by 1 unit of distance. After another second, it moves by 3 units of distance. So that if this is, for example, this is 1, that will be 3, and then that will be 5. Very good. And then it will be 7, and then it will be 9. Wow. And before that, it was, okay, here you start your stopwatch. I mean the pendulum. Okay, so let's do an position as a function of time. So x equals 0t. After once, now I'm going to do the opposite, right? The time is going to be here, x. 1 second, the distance is 3. 2 seconds, all together, it's going to be what? 4. No, 1 second, it's 1. Sorry. After 1 second, it's 1. After 2 seconds, it's going to be 4. After 3 seconds, it's going to be 9. Very good. After 4 seconds, it's going to be 7 plus 5 plus 3 plus 1. 16. After 5 seconds, it's going to be 25. So he was able to show that the displacement is proportional to the time. How do you go from 3 to 9, 4 to 16, 5 to 25? Square. Amazing. So he was able to show the kinematic equation that the position is proportional to the time square if you have a constant acceleration, just using his skills, right, for experiment, for building experiment. Okay, and he was able to show when you have a constant acceleration due to gravity, okay, regardless of the mass, they will all reach the ground at the same time. That's how he did it. And then when he died, 1642, guess who was born? Isaac Newton. Isn't that crazy? Like it's something. He died, Newton was born. He took where Galileo stopped, he invented calculus, and he explained why is that. So very, very smart, very smart. Okay, so then free fall is going to be easy for you because either you're going to drop a mass, right? But the acceleration will be negative 10, or you throw it in the air, it's going to slow down, stop, and speed up. So you're going to use exactly the same equations, except that now the acceleration will be always negative 10 if down is negative. And then what else? That's it. So the same equation, except acceleration will be always negative 10. Okay? So here, for example, you have the velocity. So here you drop something. So at velocity equals 0, at t equals 0, at t equals 1, velocity is going to be, the velocity changes by negative 10. So at t equals negative 10, at t equals 2 is going to be negative 20, t equals 3 is going to be negative 30, and so forth and so on. The displacement, okay, so to find the displacement, now, that's the thing I wanted to tell you. The displacement, the number line, it's going to be the y-axis instead of being x. Okay, so you're going to use the same equation with delta y. So delta y equals initial velocity times time plus 0.5 acceleration times t squared. So we have the final position equals initial position plus initial velocity times time, and that will be always negative 5t squared, because the acceleration will be always negative 10. Agree? So in that case, what's the initial velocity if you drop something? 0. Okay, so you're going to have delta y equals negative 5t squared. So at t equals 0, delta y equals 0. At t equals 1, delta y equals negative 5. At t equals 2, so delta y will be negative 5 times 2 squared. It's going to be what? Negative 20. Very good. At t equals 3, it's going to be negative 3 squared. 45. Negative 45. So that will be the displacement. And then that will be negative 4 squared. 16 times 5. Negative what? 80. Is that right? So you start from a height of 80. Okay, so you are 80 here above the ground. So 80 meters above the ground. And then you lose 5. So after 1 second, here you lose 5. You're going to be at 75. Is that right? 75, yes. 80 minus 20, how much is that? 60, correct. You see the position here. And then minus 45. 35. Oh, it works. Look at that. And then at t equals 4. 80 minus 80 is 0. Okay. You can have something like this. The velocity equals 0, minus 10, minus 20, minus 30, minus 40, minus 5. Yeah, so 80, and then what did we say? 75, and then 60, and then 35, and then 0. And if you look at the slope here is 0. Okay, you start with the initial velocity equals 0, and the slope is gonna increase. Do you agree? Okay, the steepness is gonna increase. So this is 0. This is 10. This is 20. This is 30. And this is 40 meter per second per second. So the slope is going to increase in magnitude, but it's going to be positive or negative? Negative, right? Because it's moving down. Acceleration is down. Velocity is down. It's going to speed up. Okay? Second situation, you're going to throw something up, right? So you have an initial velocity of 20. In that case, after 1 second, what's going to be the velocity? Wake up, you lose 10 every second. So 20 is going to be 10. 10 minus 10 is 0. 0 minus 10 is negative 10. Negative 10 minus 10 is negative 20. Beautiful symmetry. You go up 20, you go back in the hand with negative 20. Okay? What about delta y? So in that case, what's going to be the equation? Delta y equals initial velocity is 20 times t minus 5t squared. Agree? So what do you think it's going to be here? When t equals 1 second, it's going to be 20 times 1 is 20, minus 5 is 15. So that will be 15. Do you agree? Okay. t equals 2, what do we have? So 20 minus 40, 40 minus 20 is 20. So the height is 20. Okay, and then it's going to be 15. 15. Very good. And then it's going to be back to 0. That will be your displacement. So you go 15, you slow down, here you go 20, and then you speed up. What's going to be the velocity at the top? 0. Okay? Okay, so